Hello everyone and welcome to this electrodynamics series. Today we will see the fundamental theorem for curl, which is also called the Stokes theorem. Or Stokes theorem. So first of all, let me write the equation and then I am going to prove it. Okay. So what does it says? Says that when we take the curl of a vector field V and taking the surface integral along a surface, then that is equal to the line integral, actually the closed line integral along a path, and that path will actually form that surface. Okay, so if you look at the figure, so this is the some curve or some path P which is closed. Okay, so and of course there is a vector field V that is everywhere in the space. So the line integral in that vector field while moving through this path P is equal to the curl of that vector field, taking the surface integral on this surface S. Okay, right, so we're gonna prove it. Let's begin. First of all, let me tell you something. If you talk about the infinitesimal displacement vector, so it will look like this. Okay, and in the Cartesian coordinate it is going to be equal to dx x cap plus dy y cap plus dz z cap. Right, now so if we have a space and I mean we have x, y and z coordinate, so infinitesimal vector may look like this. Okay, it may point anywhere in the space. Okay, similarly the infinitesimal area vector can also be written down. Okay, it will be we can write it in terms of three component because of course this is the area. Okay, so you know the first component which is along the x cap direction, so of course this is x, y and z. So if an area pointing toward the x cap direction, then that area must reside on yz plane, and for the infinitesimal case that must be going to equal to dy dz. Similarly, for the area pointing in the y cap direction, the plane or the area must reside on this xz plane, and that is going to equal to the dz dx. Similarly, for the z direction. Right, so a line can be break down into three components. Similarly, area can also be break down into three components along the x, y and z coordinate. Okay, right, so what we are going to do, we will take, I mean we will calculate the line integral. Okay, and from the line integral we will get this equation. Okay, so let's do it now. Suppose we have this x, y and z coordinate, of course. Now this time I am taking this rectangular path. Okay, so the particle will move from this path. Okay, let me use the red color. Will move from this path. So let's say this is the first part, and at this point it will just turn into 90 degree and move on this path. This is the second path. Of course, this path movement is reside on this YZ plane. Okay, and after that it will move to the path 3 and then path 4. Right. Now we will calculate the line integral. Okay, but before that, let me introduce a vector field V, which is equal to the Vx, x, y, and z, x cap, plus Vy, x, y, and z, y cap, plus Vz, x, y, z, z cap. Right. Okay. Now we will introduce these points by its coordinate. So of course x is fixed over this point, and x is not going to change. So this point is x, y, and z. So this is x is gonna fix, y is changing, so y plus d delta y, and z. Okay, this point is x, y plus delta y, and z is also changing, and this point is x, y, z plus delta z. Right. So what we are going to do now, we will okay, so we'll first of all look at the path 1. So along the path 1, this infinitesimal displacement is actually delta y, right? And the vector field at this point is of course this v, but we know that we are taking the dot product of this vector field along dot product vector v with this direction vector, infinitesimal vector along the y direction. So it is gonna look like this, v dot dl, and in this case for the path 1, dl is nothing but delta y, so along the y cap direction, of course. So obviously that this dot product, okay, let me do one thing, let me write it properly so that it will be much clear. Right. So what we have to do, we have to calculate for the path 1 v dot dl. Right. For the path 1, dl is delta y cap, and what is v? V dot dl is equal to v dot delta y cap. So it is going to be vy delta y, right? And let me write it properly. So vy as a function of x, and for the y variable, of course y is a variable over here, so the different values of y will be there on this path. So that is gonna be y prime, and for z it is of course z plus, no, it's only z, right? For the similarly for the second path v dot dl, we have to calculate the v dot dl. So here the dl is actually, of course dl is the actual infinitesimal displacement vector, and displacement is the direction along with actually the particle is moving. So